The first question's giving you the level of S at 4,000 hertz. And we know at 4,000 hertz the sound is 35 dBSPL. Part A is asking you what the sensation level of this sound is for an individual who has a threshold of 30 dBSPL at 4,000 hertz. Now you'll remember from the lesson notes that sensation level corresponds to how a given sound's level relates to an individual listener's threshold. Okay, so here we know that this individual listener has a threshold of 30 dBSPL at 4,000 hertz, and we know the signal is 35 dBSPL. So that simply means that the sensation level of for this given listener at 4,000 hertz is 5 dBSL. There is no conversion units. Now, question B, again, we're looking at the sensation level of this same sound, but now we have an individual's threshold in dBHL. So in order to compare, in order to calculate sensation level, we either need to convert the threshold into dB sound pressure level, or we need to convert the sound level of S into dBHL. I'm going to take the approach to convert dBHL into dBSPL. So now we have to look at the recipes, and we know we have supraoral phones and we're dealing with 4,000 hertz. So the recipe is going to be 11 dB. So what that means is that 11 dB SPL equals 0 dB HL, because you'll remember that the ear is differentially sensitive to frequencies. And what the HL scale does is it's essentially the audiometric zero. It takes into account the differential sensitivity of the ear at different frequencies. So now if this individual's listener is 30 dB HL, that would correspond to 41 dB SPL. So their threshold in dB SPL is 41. And the signal that we're interested in is only 35 dBSPL. So the sensation level of S relative to this individual's dBSPL threshold is 6 dBSL minus, however, 6 dBSL, because it's less than. The threshold is 41 dBSPL. The threshold is at a level that's less than minus 6 dB less than the threshold. So it's critical to have that negative sign in there. Now for question 2, this is something that you did in hearing science. I give you the threshold of hearing in absolute pressure units of dynes per centimeter squared, and I also give you the tolerance limit in dynes per centimeter squared. And you should all remember the equation 20 times the log of the pressure of your sound of interest over the pressure of your reference. And I say to you in the question that the pressure of reference is always going to be 0.0002 dynes per centimeter squared. You'll remember that that is the softest pressure level that a normal hearing listener can detect. So if we were to plug both of these into the equation, obviously at two separate times, 0.02 over 0.0002, 20 times the log of that, we would get 40 dB SPL for her threshold of hearing. And if we were to plug in the absolute pressure for tolerance, which I set to 20, again over 0.0002, we'd get 100 dB SPL. So you'll want to refer back just to that basic 20 times the log of the pressure of your sound of interest over the pressure of your reference to compute that one. Question 3, again, supraoral phones, and I'm saying Caden's threshold for speech in his right ear equals 40 dB HL. What is his threshold in dB SPL? Well, if I'm asking you an SPL and I'm giving you something in HL, we have to use the recipes. We have to use the conversion chart. So now we're thinking about speech. And the supraoral recipe for speech is 20. Okay, so again, let's set everything equivalent to audiometric 0 first. So 0 dB HL equals 20 dB SPL, as represented up here with using the rectangles. So 40 dB HL would equal 60 dB SPL. Okay, because in order to set everything to audiometric 0, you'd have to add 20 dB SPL. So for a 40 dB HL signal, that's equivalent to 60 dB SPL. Now I'm asking you, a speech test is to be presented at 40 dB SL relative to cadence speech threshold. What dB HL does this correspond to? Again, with SL, we have to be using the same units of reference. So I'm asking for the dB HL if the sensation level is 40 dB. Well, up here I tell you that cadence threshold for speech is 40 dB HL. Remember, sensation level is asking, or you're looking at how much above an individual listener's threshold. So if his threshold is 40 dB HL and the sensation level of a signal is plus 40 dB, the dB HL level that corresponds to is simply 80 dB HL. It's not 0 dB. 0 dB would be if it was a negative 40 dB sensation level. And it's certainly not at a negative sensation level. So the answer in this case is 80 dB HL. In the final question, I tell you that with insert earphones, so now we're going to use the rectangles for inserts, Charlotte's threshold for speech is 65 dB SPL. What is her threshold for speech in dB HL? Again, we have dB SPL up here, dB HL here. So we need to be able to use our conversion factors so that we have the same units of reference. So let's convert SPL into HL. So now we're still using the speech rectangle, but we have a different type of earphone. So 0 dB HL equals 13 dB SPL. So 65 dB SPL would equal 52 dB HL. Okay? So her threshold for speech in dB HL is 52 dB HL. Now I'm asking you whether or not a speech signal that is presented at 50 dB SPL is audible to Charlotte. Well, you can't just look at the 52 dB HL, right? Because you're comparing apples and oranges. Your units here are HL, your units here are dB SPL. You could do one of two things. You could go back to the original question where I already give you her threshold for speech in dB SPL and compare that to the level of a signal that's 50 dB SPL. If Charlotte's threshold for speech was 65 dB SPL, that would be louder, that would require a louder level than a signal that's being presented at 50 dB SPL. The sensation level of this speech signal would be minus 15 dB SL. This is less than Charlotte's threshold, so it wouldn't be audible. Okay? It doesn't have enough amplitude. Now, you could also say, well, I know her threshold in dB HL is 52. But if you're going to do that, you can't use 50 dB SPL as the incoming level of the signal. You'd have to convert this dB SPL into dB HL, right? And it's fine to do that. Again, what would we do? We'd say 0 dB HL equals 13 dB SPL. Here you have it as 50 dB SPL. So that would equal 37 dB HL. And when you compare a signal that has a level of 37 dB HL to a threshold of 52 dB HL, again, same thing, a negative 15 dB SL. Right? So in either case, whether or not you're converting the signal into HL or the threshold into SPL, the signal would not be audible to Charlotte because it's being presented at a lower level than what's required for her to detect the signal.